Hey everybody, this is the 2015 FRQ number 5. So in this question, we are given the graph of f prime, a bunch of other stuff here that you can go ahead and read. They do give us some areas though, which are going to be important later on. So I just want to highlight those really quick. So the first thing that they tell us is that the area between -2 and 1 is 9 and the area between 1 and 4 is 12. So those are going to be important later. So if we highlight those now just so that we don't forget that they're there, that'd be good. Part A says, find all x coordinates in which f has a relative maximum. So we need to remember that a maximum means that we're looking for where the derivative, where f prime, changes from positive to negative. So if we look at the graph, we're looking for x-intercepts where it crosses from positive to negative. So it means we're looking right here. So f has a relative maximum at x equals 2, or sorry, x equals -2, because f prime changes from positive to negative at x equals 2. -2. Sorry, I keep forgetting the negative. Okay, so this one, pretty straightforward then. This is worth 2 points. So it was 1 point for getting x equals -2, so getting the right x value, and then it was 1 point for your reason. All right, moving on to part 2, it says, where is the graph of f both concave down and decreasing? So for f to be concave down, we know that we're going to be looking for where f double prime is less than 0. And for f to be decreasing, we're going to be looking for where f prime is less than or equal to 0. So since we're given the graph of f prime, if I want f prime to be less than or equal to 0, I want to look below the x-axis. And if I'm looking at the second derivative being negative, well, since I'm given the graph of f prime, this must mean I'm looking for a negative slope of f prime. So I'm looking below the x-axis with a negative slope. So let's see, below the x-axis with a negative slope. So from -2 to -1, and then from 1 to 3. So those are the intervals that I'm looking at. So f is concave down and decreasing on -2 to -1, union with, what did I say, 1 to 3, because, let's see, what do we know? The slope of f prime is negative, and f prime is less than 0 on these intervals. All right, so if we think about points for this one, this was worth 2 points. So it's 1 point for getting the correct intervals, and it's 1 point for your reasoning. Part C asks you to find the points of inflection of the graph of f. So if I'm looking for points of inflection, I know that I'm looking for where the second derivative changes sign. And since I'm looking at the graph of f prime, this means that I'm looking for the slope of f prime to change sign. So let's take a look at this here. So we know that the slope is negative along this interval and along this interval, and the slope is positive here, here. So if we look for those points of inflection, we're looking at -1, +1, and 3. So let's see. I think I would group -1 and 3 together. So let's see. F has points of inflection. At x equals -1 and x equals 3 because the slope of f prime, oh, that was a really bad writing right there. Let's fix that. The slope of f prime changes from negative to positive at these values. And at, what was the other one? X equals 1 because the slope of f prime changes from positive to negative at x equals 1. I know it's kind of a pain to break them up that way, but the AP exam really does prefer that you've got it broken up. I guess you could say that it's got these 3 points of inflection because f prime changes sign at these values and kind of group it together, but on the AP exam, when they give us the answer keys, they do separate them out, so better safe than sorry. For this one, it was worth 2 points, so it's 1 point. That was a really bad bracket there, sorry. It's 1 point for getting those 3 x values, so x equals, um, what did I say? -1, 3, and 1. And then it was 1 point for your reasoning. Okay, last one is part D here. So given that f of 1 equals 3, so we're given this initial condition, write an expression for f of x that involves an integral, and then we're going to find these two values. So we first have to start with this expression. So we have to remember, if we're going to write an expression for f of x, we need an initial plus an integral, which is going to end at x, and use f of t. So since we're given this initial condition is f of 1 equals 3, then that means our expression for f of x is going to use f of 1 plus the integral from 3 to x of f prime of t dt. So this is actually our first answer here. This is the, well, this one's actually an equation, but it's an expression for f of x, right? So f of x is equal to f of 1 plus the integral from 3 to x. So let's go ahead and find f of 4. So f of 4 means we're still going to take f of 1 plus, oh, I'm sorry, I wrote that wrong. Hopefully you guys caught that before I did. this should be 1. We have to start at that same x value. So that was my bad. I was putting the y value in there, and that's not right. So please, please, please make sure you fixed that. That was my bad. But I don't feel like remaking this video, to be 100% honest, so I'm just gonna go with it. So now we're gonna do the integral then from 1 to 3 of f prime. Nope, not 1 to 3. 1 to 4, because we're looking for f of 4 of f prime of t dt. So f of 4 then is going to equal 3. That's where that 3 is. Sorry that I keep throwing it elsewhere. Plus, we need the area from 1 to 4 of f prime of t. So we have to look back at our graph here. So I'm going to erase kind of some of this stuff going on here. And we're looking for the area between 1 and 3. Oh, 1 and 4. I was like 3. I'm messing with that 3. So from 1 to 4 is this area here. Well, if we look, they gave us the area from 1 to 4 as 12. Well, we have to know that because it's below the x-axis, it's actually negative 12. So this is plus negative 12. And so we get that f of 4 is equal to negative 9. Okay, and then we need to do one more. We need to do f of negative 2. So f of negative 2, again, starts with our initial plus the integral from 1 to negative 2 of f prime of t dt. Well, we can see that integral is backwards, so we're actually going to make it 3 minus the integral from negative 2 to 1 of f prime of t dt. So now I need the area between negative 2 and positive 1. So let's see. Negative 2 and positive 1. So we can see again that's below the x-axis. They did give it to us though. Negative 2 to 1 is 9. And so because it's below the x-axis, we do need to say that it's negative 9. So this is going to be 3 minus negative 9. So we actually get 12. So that means that f of negative 2 is equal to positive 12. Sorry, I know I messed up a few times with that 3 and stuff going on there. So that's my bad, but we got the right answers on there now, so we're good. So for this one, this was actually worth 3 points, but it's broken up a little differently, okay? It was 1 point for the integrand. And so what I mean by that is, did you remember that when you write this expression, this needs to be a variable other than x, okay? It was 1 point for actually writing your expression for f of x, and then it was 1 point for both of these values, so for f of 4 and for f of negative 2. So it was kind of an all or nothing in terms of those two. Did you get them right or did you not? Okay, sorry for a couple of mix-ups there, but hopefully you got through it. Email me with any questions.